Hey all you cool sabers, today we're going to take a look at quadrilaterals. So first of all, a quadrilateral is just a four-sided shape. Four-sided shape. Alright, so a couple things here. We got this diagram of our quadrilateral where we've extended each side a little bit to create these angles W, X, Y, and Z. As well as A, B, C, D. So the interior angles are the ones inside, exterior angles are the ones outside. Now, we can use the interior angle theorem, which is just going to be that all four angles will add to 360 degrees. All right, so how is that? Well, we can take any quadrilateral and we can cut it into two triangles, as you can see I've done here. Okay, so that'll cut into two triangles. And we all know that the sum of the angles in a triangle is equal to 180. So if there's two triangles, then a quadrilateral will add to 360, because 2 times 180 is 360. The exterior angle theorem is just that the sum of exterior angles, is also equal to 360. Equal to 360 degrees. All right. Now you may remember that was true for a triangle as well. The exterior angle is equal to 360. And it's actually true for all shapes. So anyway, we can quickly take a look at this guy right here, and we can say that x is equal to 360 minus 140 minus 70 minus 85. All right. So let's see. So that'll give us 220, 150, and we're left with 65. Okay, 65 degrees. I have not double checked that, so feel free to check that. Maybe I did it wrong. Probably not, though. Come on. All right, and here we've got the same thing. So we can say x is equal to 360 minus, let's see, we got 95 minus 135 and minus 102. All right. So 360 minus 95. I did not do this ahead of time. 135 minus 102 gives us 28 degrees. Whoops. That's supposed to be degrees. All right. And again, feel free to double check that if you want. I have been known once or twice to make mistakes. But there we go. All right. So let's jump over to the next page here, and we're going to take a look at the different types of quadrilaterals. Now, you mostly know all of this. But you maybe haven't had this explicitly spelled out. So the first one we're going to look at is the square. Hopefully you are all familiar with a square at this point in your education. So anyway, what makes a square is that it's got four equal sides. Oops, I'm going to zoom in so that it equal sides. It also has to have four 90-degree angles. All right, and if both those things are true, you got yourself a square. Next, we're going to move on to the rectangle. All right, and to be a rectangle, you got two pairs of equal sides. So two pairs of equal sides and four for 90-degree angles. All right. It is worth mentioning, people don't necessarily realize that a square is actually a rectangle. A square is just a type of rectangle. A lot of the times we do things and we'll be talking about rectangles, and the answer will be a square, and people will be like, well, that's not a rectangle, that's a square. And that is wrong, because a square is a rectangle. A square is just a specific type of rectangle. A square is also actually a type of rhombus. All right, which is our next one. To be a rhombus, you have to have two pairs of parallel sides, two pairs of parallel sides. Let's see, you have to have all four sides have to be the same, so 4 equal sides. All right, and 2 pairs of equal angles. Which actually, if you have the 2 pairs of parallel sides, this will be true no matter what, but I think it will anyway. I can't think of a case where it's not. Two pairs of equal sides, or equal angles. Sorry, angles. Okay. If those equal angles are 90 degrees, then you've got yourself a square. Okay, so a square is also a type of rhombus, but a rhombus isn't necessarily, so that's the thing, a rectangle is not necessarily a square, rhombus isn't necessarily a square, but a square is both a rhombus and a rectangle. A square is also a parallelogram, so is a rectangle actually, but not all parallelograms are squares or rectangles. So parallelogram. To be a parallelogram, you have to have 2 pairs of equal sides, 2 pairs of parallel sides. Or, well, yeah, so we'll say 2 pairs. Oh, I am just getting so messy here. You can't even read that. That's worse. What I did is worse. Let's try that again. It's still bad. 2 pairs of, we'll say equal parallel sides. Oh, am I going over the edge? 2 equal, oh no, okay. Sides. All right, so we got 2 pairs, and then we also have, sorry, okay. What else we got? We got 2 pairs of equal angles. Okay, and they're not necessarily 90 degrees. If they are 90 degrees, that would be a rectangle. Okay, if the sides are also equal, then you get yourself a square. All right, so let's take a look at the next one. Hopefully you recognize this one. I don't think any of these should be new. The only one that sometimes people, when we get to the next one after this one, is the only one that maybe you haven't specifically talked about. But you should have seen, oh, this isn't a rhombus. What am I doing? Uh-oh, no. There we go, okay. That's what I wanted. All right. Sorry, this is a trapezoid. Trapezoid. Okay. And we just have 1 pair of parallel sides. Okay, and that's all we need. You got 1 pair of parallel sides, you got yourself a rhombus. All right. Again, I could go through all the things, but square would be a trapezoid. A rectangle would be a trapezoid. Rhombus is I think they'd all be trapezoids. Yeah, but a trapezoid isn't necessarily. As long as it's got 1 pair of parallel sides, you get yourself a trapezoid. So the one that you maybe haven't necessarily talked about, often people will look at this guy and get it mixed up with a rhombus, but you can see we have 2 different side lengths here, and this makes it a kite. Okay, so this is a kite. It's not that hard to remember because it looks like a kite. But what makes it a kite is 2 pairs of equal adjacent sides. It's important that they're adjacent. So two pairs of equal adjacent sides, and they're, yeah, and that's it actually. Okay, that's all. As long as you get two pairs of equal adjacent sides, you got yourself a kite. And then finally, we've got this guy right here, which is just an irregular quadrilateral. Okay, irregular quadrilateral. And what makes it irregular is just that there are no equal parallel sides. No equal or parallel sides. All right, and that's it. Okay, so those are your shapes. So if we jump over here, we got some examples that we can take a look at. Okay, and a lot of these are going to seem obvious, and hopefully they are obvious, but if they're not, you can kind of take a look at what you see. And so the first one here, we've got ourselves a kite. Okay, and we know it's a kite because these two are equal and these two are equal, so it's a kite. And one of the characteristics of a kite is just going to be that these two angles are equal. All right, so y is going to equal 155 degrees. Okay, what is not necessarily obvious is a lot of the times people will look at x and say, well, then x has to equal 35, and that's not necessarily true. Okay, the 35 is not necessarily equal to the x. What we would do is we will say, well, we know that the whole thing has to equal 360. We can subtract the 155. We can subtract another 155 now, and then we can subtract our 35. All right, so we're subtracting 345, so it's actually going to be 15 degrees, I believe. Again, I haven't actually checked these with the calculator. I assume I'm correct, but you're welcome to double check and let me know if I've made a mistake. Okay, so let's look at this one. We got ourselves a parallelogram. We know it's a parallelogram because we got two sets of parallel sides, one parallel side, two parallel sides. Okay, it's not a rhombus because these two are equal. However, those two are not equal to these two. They are a different side length, so that means it is a parallelogram. Okay. Parallelograms are fairly straightforward, though, when we're looking for angles. The first one, perhaps the easiest one, is just that, yeah. So the easiest is just going to be that the opposite sides like that, or the opposite angles like that, are going to be equal to each other. So that's where we'll start. We'll say x is equal to 50 degrees. Okay. The next thing we can do is we can think about the rules we talked about in the last lesson, where we've got our C pattern here. We can create a C pattern like this, okay? And you can see that the 50 and the Z have to equal 180. So Z's going to equal 180 minus 50. So we're going to get 130 degrees. And then finally, Z and Y are going to be the same. So Y will equal also 130 degrees. All right, and that's it. All right, and I know what you're thinking. You're thinking these questions are far too easy and there's no algebra involved. So can we do one with algebra? And of course we can. So you can see right here, I've set up a quadrilateral. We're looking at exterior angles. The only thing we know about exterior angles, well, there's two things we know. And the one big one is that they're going to add up to 360 degrees. Now, we could start by writing out our equation. However, the problem is we're actually missing one of them. And this is a question that EQAO likes to do, where they'll give you something like this and you'll just forget that 80 is not an exterior angle. You'll just count it as an exterior, but it is actually an interior. So you're going to have to figure out that exterior angle first. Okay, so that angle there is going to be equal to 180 minus whatever the interior angle is. So in this case, it's 80. So that's going to give us 100 degrees. So the exterior angle is 100, not 80. Okay, so that's the big thing that people like to make a mistake on there. So what we can do then is we can say, all right, so 360 is equal to, and we can take all 4 of these angles that we now have, we can add them together. So we'll start with the 100, and then we'll say 4x plus 10, and then we've got plus 10x minus 20 plus 6x plus 10. All right. And lots of different orders you can do here. I like to collect like terms wherever I can. So we go through and we've got 4x plus 10x plus 6x. So that will give us 20x. So we've got 20x. Okay, and then I'm going to say we got 100. Oh, did I miss? Oh, I know what I did. This was supposed to be here, not there. That was a mistake. Fortunately, it didn't actually give us... It didn't matter. One of those mistakes that just cancels out with other mistakes. So anyway, here we got 100 plus 10 minus 20 plus 10. Okay, so that's actually just going to equal 100 because the 10 minus 20 plus 10 just equals 0. So we're just left with 100. So we've got plus 100. All right. So I'm going to send the 100 to the other side. So that gives us 360. Whoops. This doesn't really matter, but 360 minus 100 is equal to 20x. 360 minus 200 is equal to 260. And then we just need to divide both sides by 20. I'm just going to pick it up over here. So I'll get x is equal to 260 divided by, so that's going to be 10, 13, right? There we go. So x is just equal to 13. Now I don't know what the question actually asked. Did it say solve for the missing angle? So I don't know if it actually wanted us to find out what those angles are, but I'm sure you can do that on your own. So until next time, go Sabres.